what if the most significant images of an interstellar object weren't captured from Earth, but from Mars? In early October 2025, while the world focused on telescopes blocked by the sun's glare, European orbiters circling the red planet quietly did something unprecedented. They caught the elusive 3i Atlas on camera. This wasn't just a blurry dot lost in cosmic noise. It was a calculated, daring attempt to image an object moving at over 60 kilometers per second, with a brightness tens of thousands of times dimmer than anything the instruments were designed to detect. And yet, they succeeded. Two orbiters, ESA's Trace Gas Orbiter and Mars Express, locked their sensors on the interstellar intruder, snapping long-exposure images of a faint glowing haze drifting through the Martian sky. But what they captured has raised more questions than it answered. Why is 3i Atlas so unusually massive, up to 33 billion tons, compared to previous interstellar objects like Oumuamua or Borisov? Why doesn't it have a visible tail, despite being active? And what exactly is that glowing streak caught by NASA's Perseverance rover over Jezero crater? A comet or something else? Just as the data began trickling in, NASA's public servers began going dark. Coincidence or censorship? With Earth's view of the comet temporarily blocked by the sun, Mars has become our only outpost, capable of tracking this cosmic anomaly. But this raises another disturbing question. Why now? Why does a comet seemingly from another star system appear just when ground-based instruments are blind? And why are all the available images coming from hastily repurposed instruments, not those meant for deep space observation? As we peel back the details behind these Mars flyby observations, it becomes clear Atlas may not just be another comet. It could be the most anomalous interstellar object ever recorded. Stay with us as we dig into the strange clues orbiting this event, from the green flash over Jezero crater to the delay in NASA data to the mathematical oddities in the object's trajectory. This is not just about astronomy anymore. It's about what we're being shown and what we're not. The first puzzle lies in how Mars became the unexpected vantage point for this interstellar investigation. From Earth's perspective, 3i Atlas was positioned almost directly behind the Sun during its October 20 approach, rendering ground-based telescopes virtually useless. But from Mars' orbit, there were no such limitations. ESA's Trace Gas Orbiter and Mars Express spacecraft, not originally intended for interstellar research, were rapidly reassigned to track the object. Using long exposure settings, Trace Gas Orbiter's KSSIS camera managed to isolate a faint, hazy glow, not the solid nucleus of 3i Atlas, but its coma, the gas and dust envelope released as solar radiation heats its icy core. While the nucleus is estimated to be just 5–6 kilometers wide, the coma stretches for thousands of kilometers, gently illuminated against the blackness of space. What stood out immediately to researchers, however, was the lack of a tail. Typical comets develop a bright directional tail as solar winds sweep away evaporated material. The 3i Atlas remained oddly symmetrical, its dust still seemingly suspended around it. Scientists believe the object is still in an early phase of activity, and the absence of a tail is due to particles not yet having time to align into a stream. But that explanation doesn't satisfy everyone. For an object moving at such high velocity, over 60 km/h, and visibly outgassing the minimal non-gravitational forces acting on it, are baffling. Normally, escaping gases generate recoil, subtly altering a comet's path. With 3i Atlas, the shift is barely measurable, only around 15 meters per day, suggesting an unusually high mass that resists perturbation. Based on this, researchers have revised the object's estimated mass to over 33 billion tons, making it far denser than Borisov or Oumuamua. This revelation reframes the entire narrative. Previous interstellar visitors were lightweight and difficult to track, but stable. Slow-evolving body more like a celestial freight train than a frozen snowball. Meanwhile, Mars Express took shorter half-second exposure shots and initially failed to detect the comet at all. Only after combining dozens of images were scientists able to extract a trace signal buried in the noise. At the same time, another eye caught the event: Perseverance. On October 4th, one of the rover's navigation cameras captured a mysterious glowing streak slicing across the Martian sky, a line that, to the untrained eye, looked like a fully developed comet tail. But experts cautioned against that assumption. The image resolution meant 1 pixel represented roughly 20,000 kilometers, and the streak was a motion blur created as 3i Atlas moved during multiple exposures. Still, the fact that a surface-level engineering camera, not even designed for astronomy, could detect an interstellar object from 38 million kilometers away speaks volumes. But the questions didn't end there. Just as the data from these Mars flyby observations began to circulate, something unexpected happened. Several key NASA data servers and websites suddenly went offline. The timing couldn't have been worse. The Mars Reconnaissance Orbiter had just captured high-resolution images of the same region, where Perseverance recorded the green streak. These images, rumored to offer clearer structural details of 3i Atlas, became temporarily inaccessible to the public. The official explanation: a partial government shutdown in the United States that began on October 1st had furloughed critical NASA staff, causing delays in data processing and content publishing. But the internet wasn't convinced. With all eyes suddenly fixed on Mars, theories spread like wildfire. Was the data delay truly political? Or were scientists scrambling to review something they hadn't expected? The mystery deepened when fragments of internal logs showed that NASA teams were attempting rapid spectrum analysis of the object's composition. Yet no official confirmation of the results has been released, and radio silence followed after initial mentions in scientific forums. This leads us to one of the more controversial observations: the unusually high stability of 3i Atlas. Its motion barely fluctuates, despite active outgassing, a trait that contradicts the norm for comets under solar influence. When gases escape, they create micro-thrusts, subtly nudging a comet off its gravitational path. This measurable phenomenon has long been used to estimate mass, and in this case, the math paints a strange picture. The negligible non-gravitational acceleration suggests that 3i Atlas is not just massive, but composed of unusually dense material. Some suggest metallicity far higher than previously observed in cometary bodies, while others whisper of unknown structural integrity, something more solid than a loose aggregation of ice and dust. Combined with its stable coma and lack of a traditional tail, the object challenges assumptions about what interstellar visitors should look like. That's where the Perseverance green flash comes into sharper focus. Although explained as a visual blur from a navigation camera, its symmetrical form and timing with the flyby raises eyebrows. Could it have been a plasma wake, a charged particle interaction with the thin Martian atmosphere, or simply a reflection artifact misunderstood as something more? NASA's own engineers noted that the flash resembled a linear disturbance, not just a glow, prompting speculation about its electromagnetic properties. If confirmed, it could suggest that 3i Atlas carries a charged envelope or interacts differently with light than expected. Another theory, drawing from its high mass and trajectory, suggests that 3i Atlas may have a solid crust that delays visible tail formation, causing gas to escape more slowly or in irregular patterns. But here's where it gets even stranger. According to the orbital models, the comet is expected to reach 68 km as it slingshots closer to the Sun, a velocity that would make it one of the fastest known natural objects in our solar system. And still, it remains photogenic enough to be captured by repurposed cameras not meant for this task. The scientific world remains cautious. The public not so much. Online debates now rage across forums, with some asking whether this is an entirely new class of interstellar object, not a comet, but something we don't yet have the vocabulary for. Could this be a fragment of an exoplanet's core, a remnant of an ancient stellar system, or just the heaviest, most stable comet ever recorded? The only certainty is that we don't know, and the silence from official channels only feeds the fire. The longer it takes to release full datasets, the more the world is left wondering whether the real story is still being written or being withheld. What remains undeniable is that 3i Atlas has already rewritten several rules of celestial observation. This is the first time in human history that an interstellar object has been imaged not from Earth, but from the orbit and surface of another planet. The collaboration between Mars-based orbiters and a surface rover created a rare triangulation of perspectives, giving researchers a multi-angle view of a cosmic visitor from beyond the solar system. The trace gas orbiter's ability to detect a target 10,000 to 100,000 times fainter than its normal sensitivity threshold speaks to both the ingenuity of mission scientists and the urgency with which this object is being studied. And the object itself continues to defy categorization. Though its core may be only 5.6 kilometers wide, its dense mass over 33 billion tons, and barely perturbed trajectory raise new questions about what interstellar debris can really be made of. Unlike Oumuamua, which baffled astronomers with its cigar shape and anomalous acceleration, or Borisov, which behaved more like a typical icy comet 3i Boaz Atlas appears. Calm, heavy, persistent, and slow to reveal its secrets. This may not be the most photogenic interstellar object, but it could be the most important. Its near-perfect motion despite active outgassing, its ghostly presence in unexpected camera angles, and the curious absence of a tail all suggest a physical profile more consistent with planetary debris than fragile cometary fluff. Which brings us to the final, and perhaps most overlooked detail every interstellar object carries with it, a fingerprint not just of its own makeup, but of the solar system it came from. 3i Atlas is not merely a wanderer, it is a messenger. Its density composition and trajectory all hold clues about violent stellar processes that took place light years away, possibly in a solar system long dead. The chemical spectrum gathered, if strong enough, may one day reveal what kind of star system birthed this object, what temperatures and pressures shaped it, and what catastrophic event ejected it into deep space. And now, for a brief moment, it has come close enough to whisper those secrets through the thin Martian sky. But perhaps the most haunting part is this: had Mars not been in the right position, had the Sun not blocked our view from Earth, we might have missed all of this. A cosmic coincidence, or a quiet invitation as 3i Atlas accelerates toward its perihelion. We still don't know what its final appearance will be. Will it form the classic comet tail, break apart, or pass silently, leaving only questions in its wake? One thing is certain. Mars saw it, and the world is watching. But what exactly are we watching? A comet, or something entirely different?